Today I'm going to be showing you how to measure the width of a costume in Scratch. Basically, there's several ways we could do this. By storing the height in a list and the width in a list. And then we could manually fill in the width and the height from each costume. However, if your game has hundreds of costumes or assets and you want to be able to simply do it not by hand, then I'm going to show you a trick to be able to do this. Firstly, we'll make another list called Name. If you haven't made any lists yet, then make a list called Height, Name, and Width. Make a new custom block. Rename it, make it Measure Costume Sizes. Select one without screen refresh to make sure it does it super fast. For some housekeeping, we'll place that block under one green flag clicked. And then run the prog check to see it doesn't do anything. First, we want to delete all of the name variable, all of the height variable, and all of the width variable. Then, what we're going to do is we're going to repeat. But how many times do we want to repeat? Here's a trick you might not know. If we switch the costume to an image, we can clearly see that we can choose one. But how do we know this is the last one without manually inputting it? Well, if we go to the operators and pull in a round block, we can switch it to a costume number. So costume number 1 would switch it to number 1. Costume number 2 would switch it to 2, 3, and 4. But what happens if we put 0 in there? So if we're on costume 1 and we put 0, what will happen? It seems that we've been taken to the last costume. But how do we know what number this is? Well, by going to the Looks tab and grabbing the costume number, we can see that this sprite has 4 costumes, which works for anything. And to prove that this works, if I switch to a different one, hit this block, we can see that I have 4 costumes. So set this round to 0, then place a costume number block inside it. We want to keep track of it. So what we're going to do is we're going to after this, we're going to make a new variable. Call it IDX, index for short. Make sure to tick for the sprite only so that it remains good. Set IDX to 1 at the start of the loop. Change IDX by 1 on the inside. Next, what we want to do is you want to switch costume to round the IDX variable. This tells Scratch that it's a costume number, not a costume name. So if I wanted to switch to costume 3, and this was number 2, and this was number 3, then guess which one would win if I wanted to switch costume to just number 3. It seems like 2 won. However, placing it in a round block means that it knows it's a costume number. So that's why we round the RDX variable to switch to. At the moment, it goes straight to the last costume. However, what are we doing? Well, first, switch size to 100 at this in the loop here. Then we want to put a repeat until block right after the set size to. Repeat until touching edge. Change X by 1. If we know that this whole screen width is 480 by 360, so half of that width would be 240. So 240 subtract the X position would give us half of the size of the costume. But what we want to do is find out the full length of the costume. So run this code to position it, then we can see that half of this costume is 30 pixels big. And then we can see in the code tab that it's actually 180. What we can realize is that this is one half. It's failed to touch the edge properly. So repeat until touching edge, change the X, switch costume, set X and Y to 0. Place this right above the repeat until, which means every costume will reset and we are left with the half of it on. Now, instead of 30, we're getting a more promisable 89. So then, if we times this for 2 to get in the other half, this is a close value to what the whole thing is. Notice that because the touching blocks aren't fully accurate, we can make this a bit more accurate by decreasing this number. So if we set it to 0.5, then we'll get a more accurate number. If we set it to 0.1, then it'll be a bit more laggy, but we'll get a lot more accuracy. I like to keep this at 1 because costume widths don't have to be pinpoint accurate. But depending on the accuracy or the pause reaction. But depending on the accuracy you need for your deployment, changing this value down will change the accuracy. So this is now the height and the width. So add this to the width. And then, before this go to, we want to add to the name variable looks costume name so that we can fill in those two values. Check this works. 200, a bit accurate. 60, 278, 180. Now, what is wrong with these? The last two values seem to be extremely accurate. Well, I'll get to that. First, let's add the height calculation. Because the scratch screen is 360 pixels up, half of it is 180. So before we change IDX, drop a duplicate of the script in. Make sure to keep the go to right, but change this change X to a change Y. So we now change the elevation instead of the X position. Then set this to a Y position block and set it to 180. And then, once again times 2, but add it to the height variable. Now you can see we're getting some accuracy. But, once I said I would come back to this. So why are we getting much more accurate results on on the last two costumes than the first two? Well, that's because these costumes are square. And and this one's 180 by 180, as we can see on this accuracy. This one is just a bit wider. It's still flat, so it's fine. However, as we can see, this cute little fox is not, in fact, has a bunch of different areas. So depending on where it's hit, will have different positions to what the scratch hitbox says it is. When we hover over a spike, do you see that blue outline? That's the hitbox. That's where Scratch is measuring these widths to. But a way to get around this would be to make sure that we need to justify our answers, make them more accurate. So next, what we are going to do is we are going to make a new variable and call it accuracy. Then select for this byte only. At the top, set accuracy to 1. The higher this number is, the more accurate it will be. So for these change x's, both of these can be 1 divided by accuracy, then 1 divided by accuracy. So now we can change the accuracy of the engine. If we set it to, I'm going to set it to 2 and make the accuracy a slider, just so that we can see this in action. As you can see, it's a bit laggy. However, if we adjust this until we see, you see how the accuracy variable, we should set the remove the set accuracy block, and then we can now use it as a slider. You'll notice that the higher this accuracy is, we're trading our speed or FPS for our accuracy. So if I were you, I'd just leave it at 1. But for any cases that this needs to be pinpoint accurate, I found that 10 works very well. And as we can see, 200 and 156 is much more accurate than we got prior with the negative 200, with the 200 and 156. It's 2 pixels accurate. But some of these other costumes, accuracy have gone from 60 to 114. Height's more accurate here. To 276. Well, what's wrong? Well, remember how I talked about the hitboxes? Well, Scratch is getting confused because when this is on the edge, it knows that it's on the edge. But is it really? Not. So let's just move it on a bit more. Here seems good enough. But wait, this has been cut off. How can we fix that? How can we fix the sprite being cut off to add more accuracy to it? Well, we can repeat until we're touching the edge. Move it by 2 divided by accuracy. Then repeat until not touching the edge. Remember, don't have the project running while you're running it, because a repeat loop that's never going to end in a block that's meant to run very fast is not going to turn out well. So, change x by 1 divided by accuracy to get much more accuracy. But what for the pinpoint accuracy we're looking for in this checking, we should set this to 0.5. Then just drag this up here, then change the change y to a change x. Do you see this lag? This block should be 1 at the start of your project, or better yet, when you're about to release it to Scratch. Then after this is done, we should be able to publish it to Scratch because these lists would already be flooded. But before anything else, I forgot to add a 0 subtract. Why is it 0 subtract? Well, so 0 subtracting a number turns it from a positive number to a negative number. Now, what's the difference to just joining a minus character to it? Seems good at first, but until this number becomes negative. What is this plus 1? You'd think it should be 106. 1. Because Scratch is treating this as text, and we can't change x by a text. But 0 subtract a number with 1 minus will change it, which is what we want. So 0 subtract needs to be at the front of both the X and Y touching. If you want to use this project, the link will be down in the description. Okay. That is done. We can see that this costume is working. The top costume needs a bit of work. But this there now seem much more pinpoint now. Once again, place an accuracy block at the top. Remember, more higher accuracy, we're trading accuracy for speed. What can we do to fix the first costume? It was the correct width is meant to be 227. However, it was reporting 200. What's going on here? Well, simply higher accuracy should be able to fix it, right? So, no, it's now less accurate. Maybe lower accuracy is better. Actually, the way we scratch once has to fix this is have a look at the change X. We're changing it by in lots of big steps. 2 steps, and then we're reversing it by negative 0.5. So it'll move it'll move outside, then back up. Next, how can we make this much more accurate? Well, the truth is, we can't. Because in Scratch, nothing is going to be pixel perfect. No matter how much optimizations you make, it's never going to be any better than what we have here. Basically, we've just made a costume scanner that this one script could be dropped into any sprite you want or safely placed in your backpack. Thank you for watching, and I'll link the project here down in the description if you want to try it out yourself. Thank you, and please subscribe.